ETL project Spring 2025 driver crash reporting presented by Susan Bosnet and Sajan Pokhrel. Here, our project goal is to create the database that provide data regarding road accidents, identify the type of vehicle which has higher and lower gas impact, and which brand produced the most reliable vehicle. Identifying which location has the higher accident in which category. Also we know that the vehicle is one of our daily necessities. So choosing a safe vehicle is necessary, and this report provide the rough idea on which company's vehicle are to be trusted more and what kind of vehicles. So for the data source, we have obtained the data from crash reporting data driver, which is available at the government side. And once we have the big data, we must have a clear vision that we must find more dimension tables and some fact tables so that we can merge and find something out of those data. So while obtaining the big data, there are a lot of unknown entities and null values, and many steps are to be required in order to clean those data and make sure to make the data more cleaner. We have to go through a lot of complex ways and complex kind of functions and expression to clean those data. While doing the process, first we need is to identify the primary key. So in this process, we have identified three different dimension table and one fact table where each contains the unique primary key. So for the dimension table driver, we have person ID. For the dimension vehicle, we have vehicle ID. For dimension location, we didn't have any location ID, so we created the random number as a location ID. And for the fact crash, we created the crash ID from the merging of two different entities. So this is our ERD diagram, which clearly shows the relationship between the driver and the crash vehicle and the crash location and the crash. So it shows that the driver has one to many relationship with the crash, whereas vehicle and crash has multiple many to many relationship, and the location with the crash as one location can have only one location can have many crash. However, one crash has only one location, so it has one to many relationship. While cleaning and creating dimension and fact table, data has been filtered and stored into four different files from total data set, and they are dimension driver, which contain 128,760 rows, dimension vehicle with 80,515 rows, dimension location with 18,731 rows, and fact crash with 2,551 rows. So while doing the process, as we can see here, first we get the data, the raw data over there, the source data, and we use the data conversion over there where we convert the time, vehicle make, vehicle year, and once we get those data, we use the derive column to add more data over the main data source. So we add clean weather, load timestamp, source file name, vehicle make, report ID, and location basis. So here these are the new derived columns. So where we usually replace those data to clean the data more sensible. And while doing the source path, we created the source path on the variables uh, where the source path was from the G drive. So we just gave the data from the we just gave the source path from the G drive over there. In next step, what we did was once so we multicasted everything over the four step. We get the three dimension table. So to get the three dimension table, we use the condition split on each and every dimension table folder, as we can see. While we coming through the network, we can see that we use the condition split to erase the every null character, every non values and non expression things, so which are more reliable. We only keep the value which are more reliable on it. So in next process, as we can see, once we get all those dimension table, we couldn't get the fact table. So what we need to do was we need to get first the location ID to merge everything. So for that, what we did was we merged everything from above, where we only use the valid rows and valid columns, to make one big fact fact table. Once we get everything, we started to upload those data into the SQL, where we here we send the clean data into the SQL table. As we can see, the clean location has been transferred to the location uh, table. Similarly, this is the output of the location. As we didn't have any location ID over here, we just created the new location ID while we were transferring the data into the SQL, and SQL generated the new location ID with an unique primary key. So as for the driver, we did the same. We just transferred those data into the dimension driver in SQL. As for the vehicle, we did the same. And for fact crash, we did the same. So this is the output of the fact crash, where everything has been mentioned. And this is what we obtain after the uploading to the SQL driver. Once we upload it in the SQL driver, again we dump that data into the CSV, so that we could get the location ID and everything to merge into a big data. So in this process, we are merging the ETL table. We are merging every dimension and fact table to get the one ETL table. In here, we sort the process. We sort fact class using the location ID to the dim location, because it contains the location ID. So same way, once we get the result on those merge join, we used again the sort to sort the data according to the dim driver, and we merge again the data into the merge table with the vehicle table. And finally, after merging all four data, we get the one ETL table that we are going to send into the SQL. And this is the output of the table, uh, or the output of the worksheet that we get. Once we get everything, we transfer that file into the SQL server. Once we get the three-dimension table, fact table, and ETL table, now we are able to run our queries. So here we are asking the question about where does the most crash occur, and it gives us the SQL gives us the answer about the Gothenburg with 338 crashes. In second question, we get the what time of the day the crashes usually occur, and it gives like in 1 p.m. about 70 crashes. In third question, it gives that the Toyota Camry has more crashes, and in second is Toyota Corolla with 73 crashes. So uh, although we have a many table, we can just identify that which type of injury are to be obtained in this kind of vehicle. So it says that the passenger car has like a more severe injuries, and same as the passenger car has lower injuries as well. So overall, if we see that the passenger car is more risky, and passenger car is not so risky according. But if we see the crashes record, we can see that the passenger car has 571 injury count, but those are the minor count. Among those, Chevrolet got 13 damage count, no damage count, and the Toyota got 4 no damage count, which shows that those two are the more reliable company to get the automobile from. And as per the, you can see the crash of vehicle according to the brand. We can see that the Chevrolet got 465 crashes and Toyota got 296. So from this project, we can learn that We learned that how we can convert the data into the reliable state, how to transfer data into the different section according to its nature and requirement. For every data, there has to be multiple dimension table and fact table. Final clean data are to be obtained from those clean dimension and fact table. Once data has been segregated and merged, it has to be stored in the SQL to generate the required result. And both Visual and SQL play a big role in cleaning the data and bringing the required results. Thank you.